So for my physics momentum project, I coded a simulator in Python. So in physics, we did an experiment where we shot a trolley with an air rifle, right? And what we were trying to calculate was the bullet velocity. And you can do that by using the principle of conservation of momentum, right? So momentum before an event is the same as the momentum after the event. So if you know what the momentum after the event is, and you know what the mass of the bullet is, then you can calculate the velocity because momentum is mass times velocity, right? So for our experiment in class, we used a bullet which weighed, I think, 0.5 grams, which is 0.0005 kilograms, and then you hit enter, and then enter the velocity of the bullet. You don't know that, so you just leave it blank. So don't press space or anything, otherwise it's not going to be able to pick it up. So just hit enter, right? Don't input anything if you don't know the field, and also don't leave out too many. So you can only leave out one field. So there's going to be 4 inputs. And if you leave out 2, it's not going to be able to calculate it. You can input all 4, that's fine, but you can't leave out more than 1, right? Enter the mass of the trolley. That was 0.454 kilograms, I believe. And then final velocity was 0.158 meters per second. And note when it says mass of the trolley, it's the trolley, not the trolley and the bullet after, because it's able to use the mass of the bullet up here to calculate the actual final mass. Sorry. Enter, and then so yeah, if you don't enter anything in this field, that's fine as well because the 4 inputs is up here, right? You can only leave one of the 4 out here, but you can leave this out if you want as well. But if you leave it out, default coefficient of friction is 0, right? So like the cart won't slow down on the screen, right? It will just move with constant velocity. But if you enter a coefficient of friction that's too big, say bigger than like 0.5 or like bigger than 1, right? That's a bit crazy. And it's not possible in the real world. Um, if you do that, then the cart probably won't move at all. It's just going to be like still on the screen. Okay, so I'm going to put a standard 0.25. That's like normal, I think, like a metal or wood surface. I think I don't know, but 0.25 is pretty standard. Enter, and note that when you press enter, right, it's gonna pop up with this. If the title is in grey, that means the window is not selected, right? So if I press any button, I'm spamming my keyboard right now, nothing's happening because the window's not selected, so it's not reading any inputs. So you have to select it, and you can see the title of the window is turned from grey to black, right? You select it by just clicking it, okay? You can drag it around or anything, that doesn't matter. And then, yeah, press any button to begin the simulation. It's going to shoot out a bullet, and hopefully the cart's going to move and then slow down. And I'm just going to press like Q right on my keyboard. In 3, 2, 1, boom. There we go. And the calculated bullet velocity is 143 meters per second, which is really accurate actually. According to the manufacturer's website, the actual like bullet velocity is 140 meters per second, so that's only like an error of like 2 or 3%, which is credits to my physics teacher who yeah did this pretty well. Hopefully hopefully this video is going to be seen by the master, right? Yeah, fingers crossed. Anyways, you can press space to see what values you've entered. Press space again for it to disappear, right? Just, yeah, space. Any other button doesn't work, it's only space. Okay? So, yeah. And yeah, let's use some non-conventional, like, values, right? Because the point of having a simulation is that to see if it works with any value, right? You don't want it to work just for one particular value. So yeah, the value that I used before was it came from our physics class, right? Mr. McSkimming and Mr. Wheatland, they did the practical, and we wrote down the values. So I'm just gonna. So if you want a really large momentum before the event, you could either have really big mass or really big velocity, right? I'm just gonna do really big mass for the bullet, 1 kilogram, right? That's a cannonball right there, right? Okay, hit enter. Velocity of the bullet. Let's just keep it at 140. Okay, and then mass of the trolley. We're gonna just use the old value 0.45454, right? Original trolley mass, and then we're gonna leave the final velocity for the program to calculate. Okay. So you don't enter anything, just press enter, and then coefficient of friction. Let's put 0.2. Let's put 0. We did 0.25 before, right? So let's do 0.5. So that slows down quite a lot. I've actually never tried 0.5. I've only tried like 0.2 to 0.3, but it'll be interesting to see how this works. It'll probably slow down really quickly, but hopefully it slows down pretty quickly. But momentum is large, so the car is going to move very fast after the collision, because the mass of the trolley didn't change. So the only thing that's changing is the velocity, right? Enter, and games window appeared behind this, which is quite weird. Okay, and then I'm gonna hit just gonna hit any button, and hopefully the car is gonna move off with a quick velocity and then slow down quickly. But we might not get to see it if it moves off the screen, obviously. 3, 2, 1. Yeah. Okay, so that would have slowed down, but it's obviously moved off screen because the initial velocity was too quick, right? Like, look at that, 96 meters per second. That's the final velocity of the trolley, right? That's obviously quite quick. Oop, that's my alarm for I'm gonna be late to lessons. So I'll wrap this video up and I'll probably upload it to YouTube. So I'll be able to link it to OneNote. And yeah, that's my program right there. Yeah, thanks.